to explore RMS values and how they relate to physics. RMS values have a lot of different applications, whether it be in engineering, basically every type of engineering, especially electrical, will have it. But we just want to scratch the surface on what RMS values mean and the significance of using them when studying circuits within physics. So the first thing that we need to understand when we're looking at this is just AC current versus DC current. So let's start with DC, and we're going to draw just a quick little graph here of how DC current functions. And basically what it is it's just a constant current flowing in one direction. And so as you can see there, it's just a positive value just exerting its current in one direction. And then AC, we're going to draw that same kind of chart here. And AC current, it expresses itself as an electrical current that periodically reverses directions. And this can be good for use of transformers and things like that, but we just need to understand how those two are different. That's a pretty simple explanation. And so we're going to look at these currents and how they operate within a circuit real quick. So we're just going to draw two examples. Our first one is going to be an AC circuit. So we have our AC power source, and that's going to go in a circuit with a resistor here. And we'll think of that as it could be a light bulb or any number of different resistors, so we'll give that value an R. And then we're going to draw our DC circuit. So we're going to have a positive, negative source there, and then there's R. And we're going to equate that these two R values are actually the same value. And that's pretty important in how we're going to discuss this. So first of all, we just want to deal with this DC one, and we want to figure out how much power is running through that circuit. And what we know is just a basic application of Ohm's law. And Ohm's law states that power equals voltage times current. And we can also express Ohm's law as being voltage squared divided by resistance. And that works perfectly well with this DC circuit here. But then what if we want to apply that to our AC circuit? Do you see any problem with that? Just take a moment to think on that real quick. And the main problem that comes with figuring out your power in an AC circuit is that some things aren't constant. If we go back to our example there with our how AC current functions, we can see that most of the time it functions in the sinusoidal wave, sine wave as we can think of it in physics. It can change its current in other forms, but we'll just think of it as a sine wave. And when we have this sine wave, voltage and current both follow that course. So they're going to be constantly changing. So if our power equals voltage times current, we're going to need something to allow us to equate this power to that power when this power is constantly changing. And that is where RMS comes into play. And RMS is just a simple term meaning root mean square. And so that is kind of how we get from our AC power to our DC power. And that's a way that we can equate this power of our AC circuit, because it has the same resistance, to the power of our DC circuit. So when we have that RMS value, we can equate these powers to each other. So the first way that I want to explore RMS values is through just the long way of finding a root mean square, which is what RMS stands for. So we're going to go back to our AC current again, and we're going to draw this sine wave. And how you get that RMS value, the first step that you want to do is you want to divide the wave into equal sections. So we'll just do 1, 2, 3, 4, 5, 6, and then get that 0 value in there as well. So we break that up into those equal sections there, and we're going to label them A have A through G there. And then what we're going to do, our first step is to assign those sections. So we have A through G. And then our second step is we're going to square each value. And we'll actually call this 2 and 3 kind of combined in the same spot. But the second step, we're going to square all those values. And we'll just put some dots there because we all know how to square all that. And then the third step, after we square all those values, is we're going to take the mean or the average of those values. So we have 1, 2, 3, 4, 5, 6, 7. So we're going to divide that by 7, and that's going to give us a value. And then for our last step, we're going to take that value and square root it. And that's going to give us our RMS value for a certain circuit or voltage. So that's kind of the long way of doing it. And then I just want to explain how we get to a formula within physics and how we can equate power to voltage and the RMS value of voltage. So that's the long way of doing it there. To kind of explain, I really like how that explains how we can get to our root mean squared value. And so then we're just going to want to go back to that classic sine wave again. And we're going to look at this value, which is a peak value on your sine wave there. So when we know that peak value, then we can plug it into just some physics equations that are derived from calculus. So we won't go much in depth on that, but you can find other videos on YouTube or in your textbook that explain a little bit better the calculus behind it. But how we're going to get to that RMS value is we're going to use that peak value. So our RMS value is going to equal that peak value times 1 over square root of 2. And that's where the calculus comes in. We're not going to go into that, but you just know that it's peak over 1 over 2. So that can be applied in kind of the two different ways within the circuits that we look at. So we can do the voltage max over square root of 2. It's going to equal our RMS value, or our current max divided by square root of 2. And that's going to give us our voltage RMS and our current RMS. And that's a really important thing to understand. And then we want to apply that a little bit further back to that first circuit we had. So I'm going to erase this sine wave up here. And we're going to look back at our first AC circuit we had, because we wanted to equate the power of that AC circuit to the power of the DC circuit. So this first AC circuit, we can say that this is R still. And now we can apply Ohm's law, which gives us our average power. And we can equate it to our VRMS and our IRMS. So VRMS times IRMS. Or we can use that other equation. We're going to do VRMS squared over R. So those are kind of the main ways that we can apply RMS values into physics and especially into circuits